Hello friends, good evening.
Good evening, sir.
Yeah, so I suppose till this point everybody have understood? We were yesterday discussing this. So now you see, whenever we do the measurement, the error can be positive or negative. Okay, but the idea here is we should speak the maximum truth. Okay, so it is like, if I tell the error is 10 units, assume. But if the error comes out to be 20 units, then I am cheating. Okay, on the other hand, if I tell the error is 20 units and if the actual error during the measurement comes to 10, then I am not cheating. Got it? So therefore, we have to go in for the maximum error, and that is the logic behind, if x is equal to a summation of two physical quantities, okay, then the error will be the maximum error due to this plus the maximum error due to this. Both we are adding the positive quantities, okay, and even if the quantities are like this, then also we are adding the error quantities like this. Did you understand the logic that I told you?
Yes, sir.
If you have doubt, you ask, because you will be asked questions on why you did plus and plus, even though it was minus here. Why did you do plus and plus? I suppose you understood why we have done that plus and plus. Okay, right. Then if x is equal to a by b, then also we are going to have the error propagation like this. Okay, so can you justify this? The maximum fractional error possible will be this plus this. See, this is divided by this, but still we are adding plus. I suppose you understood the logic there.
Yes, sir.
Can you explain that?
You think for a while. I'll explain that to you. See, now for example, you are measuring the density of a body. So it is mass upon volume. So here you see, I will tell you the mass can vary from 10 plus or minus 2, and the volume can vary, say 5 plus or minus, say 3, assume. So now I want to express density, okay, plus or minus delta T. So I want to do d plus or minus delta T. Now how should I report this delta T? That's the question. How should I report the delta T? Correct? Hello?
Yes, sir.
How should I report delta T? See, now you see the situation. Now the situation number 1, it can be 10 plus 2, 12, and the denominator can be 5 plus 3, 8. This is one situation. Other situation will be 10 plus 2, 12, and the denominator can be 5 minus 3 is 2. Hello, are you with me?
Yes, sir.
So like that you can enunciate all the possible errors here. So it can be 8, and the bottom also can be 8, and it can be 8, and the bottom can be 2. Right? These are the possible maximum errors, possible things that are possible here. Okay. So now which is more? See here, this becomes what? This becomes 3 by 2. So this becomes 6. This becomes 1. This becomes 4. Okay? Hello?
Yes, sir.
Right. See now, how should I report this? How should I report this particular thing? D plus or minus D. So one thing is, if this is 10 and this is 5, then it is 2. Right? Plus or minus, if I report it as 6. Okay. Then you see, the other errors will always be less than this. So this is only possible if I have taken what? The maximum, see, the maximum deviation is here. I have taken 10 plus 2 and here 5 minus 3. Understand? This can be one of the possibilities. So what I am trying to tell you is, if you tell the error is 10 units and if you get by measurement the error less than 10, then you are not cheating. You got it? The idea here is to ensure that we tell the maximum truth. So that is how we are going to coin this situation, and that is why we are writing it as delta x by x is delta a by a, delta b by b. Clear?
Yes, sir.
Okay, done. Great. Now there is logic behind all these things. That's what I want you to appreciate. Because if you look at the questions, it is behind what was the logic behind writing all this. Then here a raised to n. A raised to n is a into a, so it becomes n into delta a by a. And here, of course, combination of these two, you will get it here. Okay? Then log a. So this is delta x by x, 1 by x, delta a by e for the logarithmic. I mean, if x is given in terms of log. Okay, friends, is that clear?
Yes, sir. Yes, sir.
Okay. Now, systematic errors are repeated consistently with the repetition of the experiment and are produced due to improper conditions or procedures that are consistent in action, where random errors are accidental and the magnitude and sign cannot be predicted from the knowledge of the measuring system and the conditions of measurement. Okay. Systematic errors can therefore be minimized by improving experimental techniques, selecting better instruments, and improving personal skills, whereas random errors can be minimized by repeating the observation several times. Okay, it's a summarization of what all we have done. Mean absolute error has the units and dimensions of quantities, whereas fractional has unit lesser dimensions. Absolute errors may be positive in certain cases, negative in other cases. Okay, clear? Right? This is summarization. Okay, now take paper and pencil and solve this problem. Following are the observations. I hope all of you can read it.
Yes, sir.
Yeah, please solve the problem, and whoever solves, say that you have done. Fine. I think by this time all of you would have solved it. So I think this should not be difficult. L bar indicates what? The mean. So you get it like this. You should get it as 3.29. I suppose all of you got this. Hello? Hello?
Yes, sir.
Yeah. I suppose all of you got this.
Yes, sir.
Values. Right. I think you followed by this and you got these values. Right? And then delta L bar is so and so. And relative error is so and so. Percentage error is so and so. So the length is 3.29 plus or minus 0.01 in terms of absolute error. So you must observe here that the length is the most accurate length of the cylinder, whatever you had got here. Okay, the mean value, that itself is written as 3.29. right? I suppose you are applying your mind and solving this problem. So it is plus or minus 0.1. So in terms of percentage, it is plus or minus 0.3%. Okay, fine. Hello. Don't waste much time. I want you to get the strategy. So this. Calculate the rise in temperature. So you did 78.3 minus 40.6.
Here we should take maximum error or minimum error, sir?
See, now there are two things here. Maximum value is only mistake. See, now what is it here? So these are, what are these 40.6 and 78.3? These are the most accurate values. These are the most accurate values. Correct? So you subtract this from this. So what will you get? You will get 37.7. Then what is the maximum error possible? So 0.02 plus 0.03. So I'll write plus or minus 0.5. So the final answer should be 37.7 plus or minus 0.5 degrees centigrade.
Yes, correct, yes.
Simple, right? See, now you practically think, you have done these two measurements and you have to report, right? So this is precisely what you are going to do. I hope you got the logic. It's not about the formulas,
Yes.
These are all very pony formulas. Yes, we also got the same answer. Okay? Try to understand the logic behind this. The length, breadth of a rectangle is so and so. Calculate the area. So here you are going to multiply. So delta E, So here you are going to multiply these two, no? So you are going to write delta A by A. You want this delta A by D. So here the error, see this is percentage error. If you multiply it by 100, it gives percentage error. So this will be delta A by A plus delta B by B. You will only calculate the, see by this you are only going to calculate what? The fractional error. Hello.
Yes.
And area you calculate separately. Area will be 5.7 into 3.4. So this will be the area and followed by this calculation. So here these quantities are given to you. So delta A is 0.1 by 5.7 plus 0.2 by 3.4. So from this you will get delta A by A, right? And then you have already found out A from this. So you will write here this A quantity, whatever quantity A you have got. So finally you should compute delta A from this. What is it? A into whatever you have got. Okay? And then you are going to report A plus or minus delta A. That's how you are going to report. Clear?
Yes, sir.
Understand the logic behind this. Just don't simply write the answers. I suppose all of you did it like this only, right?
Yes, sir.
Is this reporting correct here? Because you have multiplied it by two numbers, two significant digits, and the answer should be written in terms of two significant digits, isn't it? Hello?
Yes.
So here, whatever is reported here, what will you do?
19.
What will you write here?
It will be just 19.
It should be just 19, correct. So it should be just 19. And what about the error? What will you write for the error? See, the final answer should be, area should be 19. So the area should be 19 plus or minus what? See, you are doing addition of these two, no? Hello?
Sir, but we have divided then added, no, sir?
Pardon?
We have first divided by 0.2 by 5.7, right?
Okay.
So we should consider there only one significant figure.
One significant figure. One significant figure.
Sir, least number of
See.
significant figures when you divide.
See, here, see, okay, when you divide it here, you will consider the least number of significant digits, right? Hello?
Yes, sir.
So you should get here 2 significant digits and here also 2.
No, sir.
So, sorry, 1.
Oh,
1.
no.
1 and 1. Each 1 and 1 significant digits, you will get it. And then you are going to add it, right? So the final reporting, what will you do?
Plus or minus 1.
Plus or minus?
1 significant.
Tell confidently. So this is 8, it becomes 5. This is 1, no?
So while like adding, sir, we should think about the decimal places, sir. So we should we'll divide then see how many.
That's what. See, now you divided here. So you divided here. You divided here. So you divide it here. So when you divide here, you will end up with 1 on decimal place. Sorry, 1 on significant digit. Okay? Hello? So you see 0.1 by 5.7. What will you end up with? Only this you do. 0.1 by 5.7.
0.017, sir. So we'll take 2 decimal places on that.
So what is it? 0.1 by 5.7. What are you going to get?
0.0175.
0.0175 you are going to get, correct?
One significant figure.
So one significant figure only you have to get. So you will write it as 0.02. And for this 0.02 by 3.4. What do you get?
0.05.
0.05. Correct? Hello?
Correct, sir.
So
588.
588 you will get. So you will get it 0.06. So 0.02 plus 0.06. So that gives you 0.08. Hello?
Correct, sir.
0.08 you are going to get. Right. Now,
Here we should be.
wait a minute. So you got this 0.08. Now the thing is, you see the reporting here. Now actually what you are doing is you are adding the errors. You are adding the errors, no? Delta A by A, delta A by A. So you got it as 0.08. Are you going to report the final answer as 19 plus or minus? What are they going to get?
Sir, we should multiply this by A again, sir. Then we will get the error.
Right. Okay. Multiply it by A, right. So multiply it by A. So what is the A value here? A value is
19.
okay, not 19. Before that, whatever. Okay, fine. 19 only you take. So you get some number here. You get some number here. Correct?
That's right. So here,
नहीं एक मिनट So you got this into 19. Okay, if you multiply it by 19, what will you get here? 19 8
1.52.
1552, and I should put the decimal place here.
1.52, sir.
You seriya ಮಾತಾಡಬೇಕಪ್ಪ 1.52
52.
the multiplication of this correct. Now how many decimal places? How will you put 19 plus or minus? What will you write?
So we should take two significant places because 99 is 2.
You will take what?
Two significant.
Only two significant. Why you will take only two significant?
Because 19 has two significant figures.
19 has two significant figures, so you will write it as two significant ones. That is, you will write it as plus or minus 1.5.
Correct.
Okay. So understood the mistake here? So he has forgotten. He is concentrated only on addition, but final reporting should be done like this. Hello, everybody there?
Yes, sir.
I suppose you have learned this in the college. Like this only. Have you solved similar problems? Come on, be serious. Okay, a body travels so and so in time so and so. Calculate the velocity with error limits. What is the percentage error in the velocity? Okay, there you multiplied. Here you got to divide. This by this. Okay. So I hope you understood the logic behind this, how to do this and all. We'll not waste time on the calculations here. Just straight away get into the answers and we'll discuss the answers, because otherwise you will spend time doing the multiplication and division. Nothing great about this. Okay. So you see whether they are following the rules properly here. So they are divided this by this. So here there are two significant digits, isn't it? So therefore, here they are done it correct. Hello? Watch out. So here the first step is correct. The first step is correct. Okay. Now come to the second step here. So they went on doing this. They got it as plus 0.02. So delta V is so and so into 3.45, and they wrote it as plus or minus 3.1. So why did they write plus or minus 3.1 here? Hello?
So 3.5 they multiplied with itself.
See, they are multiplied here. So the least significant digits here were 3, no? Why did they stop at 2?
Sir, I guess they should multiply 3.5.
They should multiply 3.5, right?
That's the volume velocity we look.
See,
Considering significant figures.
frankly speaking, see, listen, you saw the rule there. You should first complete all the multiplications, divisions, etc. Finally, you should round off, correct? See, they wrote here to get to write here. Understand? But actually, you should multiply by 3.45 only. You should not do the round off before you complete the calculation.
Okay, sir.
Right? Hello?
Yes, yes.
So therefore, here when you do this 2 multiplication, the number of significant digits will be 3. Hello, are you with me?
Yes.
The number of significant digits should be 3. Right? Now you reduce it and you get this one here. Are they justified in writing it 0.31? Should they have written it as 0.308 or 0.31 is correct? Hello? Are you all thinking?
Yes, sir.
How many decimal places? Here you see V. What is the number of significant digits in V? The number of significant digits in V has to be 2. Correct? Hello? Hello? The number of significant digits
Yes,
when you
sir.
report velocity should be 2. Correct?
Yes, sir. Correct.
Yes, sir.
And therefore, you see now, what is
Yes.
delta? What is delta V? Delta V is V2 minus V1. Correct? Change. Hey, see, now what I am trying to tell you, V is what? The velocity. Correct? Velocity, the number of significant digits has to be 2. Agreed?
Yes, sir.
Now what is delta V? V2 minus V1. Correct? So it also should be 2. The significant digits of delta V also must be 2. Correct? So you are dividing 2 significant digits by 2 significant digits. So the final answer should be 2 significant digits only. Correct? Okay. So delta V by V should contain 2 significant digits, or delta V should contain 2 significant digits. Correct? And that is why this is rounded off to 0.31. Correct?
Yes, sir.
ಎಲ್ಲರೂ ಎಸ್ ನೋ ಅಂದ್ರು ಯಾಕೆ ಹಿಂಗೆ ಮಾಡ್ತೀರಪ್ಪ ನಿಮ್ಮ ಟೈಮ್ ನೀವು ಎಷ್ಟು ಹೇಳಿ ಮಾಡ್ಕೊಳ್ಳಿದ್ದೀರಿ
Yes, sir.
ಸಿ ಯು ಆರ್ ಡಿಸ್ಟ್ರಾಯಿಂಗ್ ಯುವರ್ ಓನ್ ಲೈಫ್ ಕಮ್ ಆನ್ ಬಿ ಎಂಥೂಸಿಯಾಸ್ಟಿಕ್ ಬಿ ಆಕ್ಟಿವ್ see this is what is happening in the classes. No, 1 or 2 students will be active, others will be sleeping. That is why you see you don't know what you are losing by this. You have to be enthusiastic, you have to move forward now. Then only you can get good marks, good college, etc. If you simply sit there, no, it is not like your 8th standard, 9th standard, where automatically you are promoted. Here you have to fight, you have to struggle to excel. Okay, so I hope you understood this logic here. Percentage error in this is also so and so. Okay, fine. So here this is so and so. See here the reporting. Here the reporting is percentage error in velocity. It is reported to be 9%. Why? Why did you not keep it at 8.9? What is it? So this they should have written it as, see, they should have written it as 9.0, isn't it? 9.0. They should have written it as 9.0. Correct? Hello?
But even though, sir, it should not increase, sir. Even though if we take too significantly less, sir, it should be 8.9. This 9 is an odd number.
Yeah, 9 is an odd number, then you should increase now. 5 if you round it off. If it is even only, you will keep it like that. If it is odd, you will add one now.
Correct.
Yeah. So you will write it as 9.0 percentage. Hello? 9.0 percentage. Because see, 9 percentage and all, you know, they are well, you know, they are just like numbers. So therefore, they did not simply write it as 9.0, they wrote it as 9%. Okay, see, this is also a very interesting problem. Say, the reporting is very, very important here. I suppose you understood the significance of this. In the previous problem, they have goofed. Okay, and in this problem, everything is taken into account and properly solved. This is what is the importance in this particular chapter. You know, and your final answers must be to the point. See, for example, now you are reporting, you have got only in the OMR sheets. Okay, so you just have 3 columns. So you go from there, your answer is gone this. And many students have goofed up like that. Okay, shall I proceed?
Yes, sir.
Yes, sir.
See, till you complete this one, you should not round off and all. Here they are round off because they wanted to use this value. They wanted to use this value here. That is why they had done that. Oh, see, right. I think copper of length increase in length by 2% when heated. If the copper cube is having side heated from T1 to T2, what will the percentage in area of the face and volume of the cube? So did you derive the intelligence from this problem? So what did you understand from the first statement? A thin copper wire of length L increased by 2% when heated.
Entire 2%, sir. Like.
See, now if the copper cube having side 10L is heated from this, what will be the percentage change in its area of one face of the cube? So there are 3 things involved here. So here, to calculate all this, you need alpha, beta and gamma, correct? Hello? You need alpha, beta and gamma, right? What way alpha is given? Alpha is not given, no? So can you determine alpha from this? You can determine what they have written here. See here, see what is alpha? Can anybody define what is alpha? Anybody? Coefficient of linear expansion, fast. So you want to waste your time like anything. Somebody who knows something, tell. Aryan, what is wrong with you? You are not even opening your mouth. Aniket. What is alpha? Arun?
No formula.
I heard. Gutila.
Alpha is delta L by LT, L delta T.
Aryan, you should define. Anybody can define? See, fractional change in length.
Why is that?
Okay, fractional change in length. Okay, per degree rise in temperature. Isn't it? That's how we define alpha. Fractional change in length per degree centigrade rise in temperature. That is how we define alpha, right? Hello? So in this case, what they have given? In this case, a thin copper wire of length L increased by 2%. That means delta L by L into 100. What they are given here? Delta L by L, okay, into 100. They are given it as 2%. Got it?
Yes.
So therefore, and when heated from temperature T1 to T2. So what is alpha here? I am giving you hints.
2 by 100 to delta divided by delta.
That's all. 2 by 100. Why are you all hesitating to tell? So it is 2 by 100 divided by delta T. That's it. So it is 0.02 by delta T. Correct? That is alpha. You got alpha. And beta will be what? 0.04 by delta T. And gamma will be what? It will be 0.06 by delta T. That's it. Okay. Now they are told if a copper wire side is 10 L, not L. Area of one face of the copper. So area will be L square.
We can take beta.
You can take beta. I just told you area is AH. Okay, do it. If you know how to do it, you do it fast.
This done.
Done. So what is the percentage change in area?
4%.
4%. What is the percentage change in cube?
6%.
6%. That's all. Simple. Simple. Let's see. That's all. Directly you got the answer. The maximum percentage will be observed in volume, lesser in area, and least change will be observed in length of radius. Okay. So they are asking you delta A by A, delta B by B. So I have solved a few issues there. Now we will come to this vernier. I think all of you have used vernier scale in their college. Hello?
Yes.
So you know this, least count is equal to M minus D, all this you know. Or should I explain this? Or whatever you know, whatever you have studied in college, you tell me about vernier. Quickly. What is least count? What is least count of a vernier? Tell me, what is least count of a vernier? ಯಾರಿಗೆ ಕಲ್ಸಾಕತ್ತೇನಪ್ಪ ಫಸ್ಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಕೆಂಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಹುಡುಗರು ಕಲ್ಸಾಕತ್ತೇನೋ ಇದು ಗೊತ್ತಲ್ಲ.
Definition or value?
See, whenever a physics teacher asks, you should tell the definition. What value? What is that value you want to tell? What is that value means what? What is the value of least count you want to tell? You should completely define, man, what is least count. What is least count?
The least value that an instrument can measure.
Least value the instrument can measure. That's all. Very good. Correct. Excellent. Well said. Now coming to 1 year. Okay. Tell me. What is least count of a 1 year? 1 year scale.
0.01 centimeter.
So now if they ask you what is least count of 1 year, you are going to write the answer 0.01 centimeters. So whatever 1 year was given to you in the college is 0.01. Not all 1 years will be 0.01 for your kind information.
Yes,
Now, how did you get this number? Okay, anyways, how did you get this number? 0.01. What is the science behind that? Least count. See, these are the things they are going to ask you, man. They will make you to prepare a 1 year in the examination. Not physically, but they will give you some things, some inputs and tell you, okay, what type of 1 year will you do? What will be the resolution of this? What will be the least count, etc. The questions will be like that. So you should know how. See, if you are using any formula, you should know how the formula has come. Your questions will be based on that. It's not like a formula laga lo answer aa jayega. Aisa nahi. That is, these examinations are not for such questions. Can anybody explain working of a 1 year and how you get the least count? How you get the least count and what is that least count in a 1 year? First, I am not exaggerating. I'll show you the questions.
it's the number of main scale divisions by. So you want the formula first?
How did you get the? Okay, you tell me the formula. Okay, you tell me the formula.
Sir, 1 year will have 2 scales.
Now,
one will the main scales. That will give you the value up till 0.1 centimeters. Till that value it will give you. To find the next one, the 0.01.
How did you get the formula? First, tell me the formula for 1 year for LC. You know coinciding vernier division and all. What is the mechanism? What happens there? What happens there? Okay, fine. See, that's what I'm trying to tell you. You have studied the theory. You have the pleasure of handling a vernier with your own hands in the laboratory, correct? And the first experiment was on, studying the vernier scale, vernier instrument, and then, using it to do something. All this you have done, no? In the laboratory, in the college? You have done or no?
Yes.
Then you have handled a vernier, correct? And they have written formulas and all, you have used and all. Now, just for a while you think, you want to write an examination, mains, advanced, NEET. What questions can you expect there? They are definitely going to dig deep into that vernier. Okay, so you see, this is what, if there is a science student, he will, as soon as he gets the vernier, he will see that, how this formula is written, what is the science behind it, how I am able to measure 0.01 millimeter in that. So these questions should come to you. Okay, and when you think and think properly, you will get answers. And if you do this process, then questions asked on this you can answer in exam. Anyways, no point in going on telling you because you don't want to change. Okay, let me tell you. Now here you have got the main scale division. I suppose all of you know that, right? So I am writing it big. So you will have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be the main scale, 0 to 10. What you call it as main scale of the vernier. Correct? Hello?
Yes, sir.
1, 2, 3, 4 like this. Then you have got the vernier scale. Correct? How will the vernier scale be? Can you tell me? I want to draw the vernier scale under this. I want to draw the vernier scale under this. Right under this. How should I draw? Have you handled it now? Hello?
Yes.
How will it? What is that you see? See students, the most important thing, what is necessary for a science student, you don't have that. See, it is all about inquiry, investigation, inquisitiveness, observation. See, these are the keywords. See there, what you will have there is, you will also have 10 divisions there. Okay, 1, 2, 3, like that. Hello? Hello? And you will have the 10th division here. So like that. So this is 0, 1, 2, 3, and you will have the 10th division. I can't draw it properly. So like that, there will be divisions here. Okay, there will be divisions here. There will be 10. So what you have to see here is 9 divisions on the main scale corresponds to 10 divisions on the vernier scale. 9 divisions on the main scale corresponds to 10 divisions on the vernier scale. This is how the vernier is going to look, correct?
Yes, sir.
Yes, sir.
Right. Now, you see, so with no zero error, this is coinciding with this. Okay. Now you see the science behind this. Now, say you keep something in between. So you know that vernier, no? You will have 2 prongs like this. You will have the hangs like this. All that you keep some object here. Okay, I am exaggerating it. Supposing the diameter of this is 0.1 millimeter. So this is in centimeters. I am showing it in centimeters. Okay, this is in centimeters. So, sorry, this is in millimeters. This is in millimeters. So what happens here? You see, now here when you keep this object of 0.1 millimeter in between this, then this vernier scale will move to the right, and the first division will coincide with the first division. Correct? Isn't it? The first division here will coincide with this. That's what you have observed. Hello? How did that happen? See, the science behind this is like this. So now, if you take a vernier and you keep some object here and you start moving it. Okay. Now here you see, if the first division coincides with the first division of this, then what are you going to write? The measured value. What will be the measured value? The measured value. What will be the measured value? The main scale division. Hello? Hello? Plus, what do? Coinciding vernier division. Correct? Into least count. This is what you write.
Yes, sir.
Now you understand this very carefully. See, now supposing you have kept here an object of 1 millimeter. If you had kept an object of 1 millimeter, then this entire vernier would have moved by, that is, this would coincide with this. Correct? Okay. So there this would have coincided with this if you had kept 1 millimeter. Now if you are keeping 0.1 millimeter, so 0.1 millimeter, see, please understand now, no, the science behind this, sir. See, if you are good students, sir, when the moment you got the vernier in your hand, you would have very nicely observed it. So what is the science behind it? If you keep 0.1 millimeter object here, the first division will move to the right and coincide here. The second division also, see, each one of the divisions will move by 0.1, but the second one will coincide with the second one, provided you have moved the vernier by 0.2 millimeters. Third would have coincided with third if you had moved the vernier by 0.3 millimeters. Got it?
Yes, sir.
That is the science behind this. So therefore you see, if the vernier scale is made like this, that is 9 divisions of the main scale is equal to 10 divisions of the vernier scale. Then the least count will be what? The least count will be what? 1 millimeter minus 9 divisions on the main scale divided by the number of divisions on the vernier. So this becomes what? 0.1 millimeters. That will be the least count. That's how we are going to do. Did you understand? Hello?
Yes, sir.
Yes, sir. That is the diagram. So it is 0 and 1, so on and so forth, 10. This is main scale. Okay, and they have written here millimeters. Right. Now here you have got the 9th division, you have got the 8th division. Now what have they done? They have given a vernier here in the examination, wherein the 8th division, that is 8 divisions on the main scale. Hello, 8 divisions on the main scale is equal to 10 divisions on the vernier scale. Correct? Then what is the least count of this? And then they have asked problems on the measurements. Now here what will be the least count? So this is what is the examination question for you. This is what is the examination question for you. So you cannot use that formula and say, oh, for this also 0.1 millimeter is the least count. No, for this the least count will not be 0.1. What will be the least count here? Tell. So here you see, here you will have 10. 1, 2, 3, 4, 5. Okay, and this will be the 10th division. This will be the 0th division. You understood? What will be the least count here? So just now I taught you how you will write them least count. Pointer? Hey, guess work ಮಾಡಿದ್ರೆ ಬಡಿಸ್ಕೊಂತಿ. See, here, if you have got the vernier divisions as 8, so this is 0 and this is the 10th division of the vernier scale. Hello? Are you with me?
Yes, sir.
Now, that means, now try to understand. Here, see, formerly when I showed you the former one, what did I show you there? There, I showed you 0 and then this was 10 on the main scale and this was 9. Okay, and the vernier here had 10 divisions. Correct? It had 10 divisions, 1 to 10. 0 to 10 on the vernier scale. Correct? So there, the first division on the vernier and the first division on the vernier scale and the first division on the main scale. So what was the gap between these two? The gap between these two was, how much was it? 0.1. How did you get 0.1? So we wrote there 1, this is 1 millimeter, minus 9 of this coincide, 9 of this is equal to 10 of this. So you got it as 0.1. So in this case, what is it? In this case, 1 of this minus 8 of this coincides with 10. Correct? So this becomes 0.2 millimeters. Correct? 0.2 millimeters. That means now here you see the first division of this is here. First division of this is here. So if this coincides with this, then it means the object that is measured is of 0.2 millimeters. Did you understand?
Yes, sir.
So that is how you have to understand these things. Anyways, we shall solve few numericals. You will understand. See, somehow students, you should learn science like this. You have to be you should be inquisitive. Your questions are all based on this sort of a mindset. With this mindset, the student has studied, he has learned, then he can answer those questions. There are many students who learn like this. Okay, and that's why, they are able to become better engineers, better doctors, whatever it is. And those students who super richly learn, you will be at a very low level. Right. Okay, see here. So, let the length A on the main scale division be equal to length B on the vernier scale division. Okay, I just wrote it in a different manner, but this is what length A means. They are telling you the maximum C. Now I showed you with only 10. Okay, so the vernier can be 100, much bigger. Okay, I showed you only 10 divisions. It can be 20, 30, 40, any number of divisions. Then say A will be say 40 on the main scale, corresponds to what on the vernier scale. So B is equal to A by B by M. So M minus B is equal to M minus A by B. Are you getting the same formula that I wrote here? See, what I wrote there earlier was 1 millimeter minus, in the first case, the 9 units of the vernier coincided with 9 divisions on the main scale coincided with 10 divisions on the vernier. This is what I wrote now. Hello? Then of course, 1 millimeter has to be subtracted from 1 millimeter. So since it was 1, I had not written, but you should write the main scale division. Main scale is 1 unit of the main scale. 1 unit of the main scale. So 1 unit of the main scale is nothing but 1 millimeter. So what we have got here was 1 millimeter minus 9 by 10 is 0.9, and into 1 millimeter is 1. So we got the least count as 0.1 millimeter. Got it? Now see whether the same thing is holding good here in this also. Okay, see, the final formula I wrote was this. You remember? Okay, the same. This is the final formula that I have written. I hope you can correlate and relate this. So here, only thing is A here corresponds to 10 units on the main scale is equal to 9 units on the vernier. This is the first thing that they have written. And therefore, B is equal to 10 by 9 M. So this is what they are writing it as A by B M. Okay, rest of them are manipulations. Now try to solve this problem. With this knowledge, you try to solve this problem. 1 centimeter on the main scale of vernier calipers is divided into 10 equal parts. Okay, that means each division is 1 millimeter. If 20 divisions of vernier scale coincide with 8 divisions on the main scale, what is the least count in calipers? Do it. Now don't simply remember the formulas and write. No, you formulate the problem and solve this problem. Let me see. Come on.
Yes, sir.
Yes, Sarah?
Yes, sir.
good.
Yes, sir. Yes.
Now what is the least count? What is the least count?
0.67.
0.06.
One student says 0.6, another student says 0.06.
0.67.
Point?
6 millimeters.
0.6 millimeters.
0.06 centimeters.
0.6 millimeters. Another student is telling same. No, both of you got the same answer.
Yes, yes.
So now you see, you are going to get more interesting problem than this. I will tell you. No? They have taken 2 papers and they are asking you to make a vernier caliper. Like that, you have got a question in the examination. Anyways, so here you see, you should be able to get the imagination that first question, 1 centimeter on main scale is divided into 10 equal parts. That means indirectly they are telling you one division on the main scale, one smallest division on the main scale is 1 millimeter. And then 20 divisions of vernier with 8. So 8 divided by 20. Right? So the thing is 1 millimeter minus 8 by 20 into 1 millimeter will be the least count. Okay, so that gives you 0.6 millimeters. That is the least count. Correct. Okay? You have solved such problems in the college? Say yes or no? 0.06 centimeters or 0.6 millimeters. Okay, done. Okay, zero error. I think all of you know what is zero error. No object between the jaws. The vernier should show 0, but due to some extra material in jaws or bending and all, you get this. So there is an issue of zero error. Understood? Hello, I think that's the first check that you should do. I think this zero error is clear here. See, this line is not coinciding with the 0 there. Okay? So it gives, so excess reading is 0.3 millimeter. That means with no object there, you can see here that which division? So excess reading is 0.3 millimeters. So the least count is, see here they are written, least count is 0.1 and here the third division of the vernier is coinciding. Therefore, before you do the reading only, third division is coinciding, that means excess reading is 0.3. So you do the actual measurement, you get 13.8 millimeter, in which case 0.3 is excess. So actual thickness will be 13.8 minus 0.3, 13.5. Okay, so that is how we will handle the zero error. And the zero error can be plus and minus, so that you should take into account before you start the measurement. So zero error correction, observed reading minus excess reading is equal to observed reading plus minus excess reading plus zero correction. Zero correction is equal to minus zero error. Okay, right. Okay, handle this question please. Reading taken from measurement. Zero correction is 0.1. Okay? Hello?
What should we do?
Yeah.
What should we do?
This is just an illustration, man.
Oh.
It's just an illustration. What do you do now? It's just an illustration. So here you see already when the jaws are touching each other, okay, there is no object there, it is already giving a zero error of 0.5. The fifth division is coinciding. Okay, so therefore you have to do whatever reading you get, from that you have to subtract 0.5 millimeters, just to illustrate it. Okay.